if you and I were to review the same video and we had to caption it and explain what's happening, how would you describe it versus me? How can we get to the same conclusion but use different words?
How can you leverage different cultural biases? Like we've done experiment with voice and people see things in a different way. Can we leverage this? Is there value for the models in that? There's really something interesting on this front.
Multimodal is all fun and games until you appreciate that there's no such thing as an objective experience of reality. Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Hello, podcast land. Welcome back to another classic installment, I'm sure, of How AI Happens. It's me, your host, Rob Stevenson, here at the helm once more to bring you the sweet, sweet sounds of AI, ML, computer vision, generative expertise and advice. And today we have a very special episode for you. It is not our typical interview session because I'm bringing in some of my friends from SAMA, and we're going to speak about Meta's Segment Anything 2. Now, SAM-2 dropped at the end of July, and here we are. It's early December. Why now, you may be wondering? Why did we not do an emergency podcast episode the day it came out with maybe an all caps title and a YouTube thumbnail of me doing the Home Alone face? I guess with bounding boxes covering my face would make sense in that context. And the reason is, number one, this is not that kind of show. And number two, when a new model drops, there is so much speculation and guesswork and happening all around the power of the model, the use cases, the practicality, the cost. And all of these things tend to become more clear once people get their hands on it and some time passes. Now, my friends over at SAMA, who I just mentioned, they regularly hold what amounts to basically an AI research paper book club. And in a recent meeting, they discussed at length SAM-2, and me being the enterprising content creator I am. Anytime someone says something interesting, I automatically ask myself, should we be recording this? And luckily, two of SAMA's amazingly bright and experienced subject matter experts agreed to continue the conversation here on the podcast. So let's meet them right now. I'll bring them out. First up, we have Senior Applied Scientist over at SAMA, Pascal Jauffret. Pascal, welcome to the show. How the hell are you?
Hi. Yeah, I'm well. I'm fine. And you?
I am great. I'm really excited about this conversation. Can you tell that I have this boyish excitement for this episode?
I can tell.
I would love it, just before we keep going here, if you could share just a little bit about your background and your sort of area of expertise.
Yeah, for sure. So I'm a senior applied scientist here at SAMA. I've been there for the last 3 years, working mainly on computer vision, single frames, videos, 3D, 2D, all the applied stuff that we do here at SAMA. And previously, I did a lot of work on natural language processing in bigger corporations, in banking. But I've been in various domains and always trying to apply the recent AI research to solve business problems and push the envelope in the end.
Wonderful. So glad you're here with me today, Pascal. Also joining us on today's episode, waiting patiently in the wings, but also chomping at the bit to chime in here, is Solutions Engineering Manager Yannick Donnelly. Yannick, welcome to you.
Thanks for having me. Excited to be here.
Really pleased you're here too. Same question. Would you just mind giving us a little bit of context for who you are and why you're here?
Sure. So I come from a software engineering background. I've been mostly working for the past few decades in aerospace, manufacturing, and robotics. So there was a lot of automation being done and some kind of beginning of MLs in my early career, and then eventually moved into more of the startup scene and started working into conversational AI, different type of AI that could be used in fintech and insurtech, and slowly but surely moved my way to SAMA to then start trying to help companies resolve their data needs, right? This is what we do a lot at SAMA, is helping large enterprise customers get their data annotated at quality and to help train the models of tomorrow. So yeah, I've been here for about 4 years.
Wonderful. And you are also joined by your adorable dog, Lily, who may be chiming in at some point we should call out. Not going to make any efforts to edit it out or remove her. She's part of the fam
She's
at this point.
trying to jump and make her bed.
Part of the show.
Part of the show, exactly. Maybe we'll have Lily back on if she does a great job. In any case, gentlemen, thank you for being here. And let's get into SAM-2, shall we? So, Pascal, was it you who sort of brought the research paper to the discussion group?
Yeah, essentially. So yeah, we have this reading group internally that we do every week, and it was my turn. And this had been in the back burner for a while. And so I really took the time to read the paper and present it to our group. It's a fairly technical reading group, but everybody is welcome. And a few conversation emerged, especially with Yannick, out of this presentation. So that's why we're here now to kind of share back.
Yeah, and I've been playing around with SAM-V1 since it was announced a while back. And when I was really excited when I saw V2 is because I've been working with a lot of customers who are moving into more like video and sequences, which is a big part of what SAM-V2 can do, is now kind of do what SAM-V1 did, but now on a video or sequences. And I was tinkering around as I do with a lot of different technologies. And I've been kind of sometimes discussing with Pascal and some of the teams to be like, hey, I think we should look into this. I think we should kind of explore possibilities with this technology.
Should we start by explaining a bit what SAM actually is, or should we just assume everybody knows?
I think probably most people are familiar with it, but I'll challenge you to do like a SAM-2 elevator pitch in 30 seconds or less, just to set the table here.
A SAM-2 elevator pitch is actually fairly easy. It's SAM for sequences.
Wow, short elevator ride. We're not even to the second floor. The segment anything model, and it seems the SAM-2's advantages, there are some efficiency gains, there's fewer interventions, and video is really the splashy addition to it. So something that stood out to me as a non-technical person was that early in the research paper, they make the point that video is essentially a sequence of images, that if you just take the frame by frame of the video. But it's not just as simple as processing a video as 10,000 images or whatever. So I was hoping, Yannick, maybe could you explain what is the difference in getting context from video that means you cannot merely just process 10,000 images?
Big kind of takeaway from splitting videos, right, is that when we start breaking them down into frames, they kind of lose the connection between each frame. So you might say like you have a video with, let's say, we talk often videos of frames per second. And the higher the frames per second, there is information that is similar between the frames. But once you start breaking them down into individual assets, that connection is gone. So if you do an annotation on one image and then you go to the next frame, which is another image, and it's completely separate, you're kind of starting from scratch again. The idea, you lose that kind of temporal connectivity when you're kind of like, especially like you said, 10,000 frames, but that happens on 5 frames. The second you start talking sequences, you are now kind of starting from scratch on a new moment in time. And then you have to resegment or redo the work from scratch again. Things have moved. There's motion, there's blurriness. There's all these things that need to come into account when you're trying to interpret what's happening in frame X. The second you go to frame X plus 1, new context, new world, new time. So you kind of have to reinterpret the world as it is in that moment. So that's where the difficulty is with sequences.
Yeah, one of the hard things is knowing in the new frame which object was the same as the one in the frame before. Seems like a fairly simple problem when you think about it in terms of a human, but when you're a model, you may not have any kind of assumption as to we're driving on the right side of the road, objects are moving in a specific way. With regards to that, basically this is the problem of tracking. And if you use just a generic model, if I'm trying to track my hands on a video and you're trying to track my hands at a very, very low frame rate, if you have a basic tracker, you know from the information about the human that which one is my right or my left hand, but the basic tracker might not have this information and might get confused because they are actually fairly similar.
Okay, that is helpful. And I'll link the research paper in the show notes here, and there's a lot more in the paper on the specifics of how that is accomplished by SAM-2 for folks if they want to do a deep dive. I am curious, Pascal, when you decided, this is a long time coming, like I want to bring this paper to the group, because Meta's AI research arm is putting out papers every 10 days, it seems. They're shipping a lot. I'm curious why this in particular interested you and why you thought it was topical.
Yeah, so I'd say it's a mix of both things. When we do our reading group, we'd like to sometimes like just get the latest state-of-the-art model that came out, but also the business is pressuring us and we're getting insights from clients. And this model had been there for a while and seemed to be a great opportunity for automation. Yannick had been talking to us about it. It's been in the space for a while, so that's why I decided to take a look at it at that time.
On the solution engineering side of things, we try to be a little bit more proactive when we start talking to customers. And we understand that productizing sometimes capabilities in a platform could take a bit of time. We need to have people involved and make the analysis to see if this is the right move to do. And that's why we have these conversations with larger technical teams. But on my end, I still need to move pretty quickly, test things out. And I saw a benefit, right? I saw that there was, in some use cases, traction from the deliveries we were doing, utilizing some of this, even though it was running a little bit more ad hoc, that I'm like, I think we need to dig deeper into this. So we're tackling this from multiple angles, but I'm maybe more on the practical side of things. And Pascal is maybe more on the research and how the models are evolving. What are the cool things that are being put together by all of these large companies that could benefit the community as a whole?
And those models, like SAM, they're really great. I'd say baseline, like those are tools that can handle generic use cases very well. And this is where it brings some big value for us at SAMA.
I see. Now, we can read research papers all day. Well, some of us can. But there's nothing like the quality of experience. So, Yannick, I'd love to hear from you first. What stood out to you once you got your hands on this tool and really got to play around with it?
I would say is just how out of the box it's able to do a very, very good job at breaking down, I would say, edges of objects. So being able to really precisely, I'll take an example, like a leaf that has a lot of like little spine, like or spiky edges. With one click, you're able to generate a mask of that object, which usually manually, if you had to do that by hand, would require quite a bit of time, right? And I saw these kind of examples coming up in some of the use cases I deal with customers. And I was like, there is a benefit of accelerating when possible, because again, there's going to be limitations. But if the team that are using the tools are trained properly to know when to identify, when to use or not the capabilities, we can get a pretty big efficiency jump. But again, it's on a use case per use case basis. And some of the stuff that I was looking to kind of align, like kind of the stars aligned where I had a use case that could benefit from using it. And the model had come out like a couple of weeks ago. So I was like, oh, shiny new model to use and a use case. It's like it was a perfect kind of melting pot to bring both of them together. What was the use case? It had to do with like a closed segmentation, right? And we used to do some of that. We used to do it all by hand. And now we expanded it. And the fact that the customer, and again, the use case also is perfect. Like the use case was putting their products that we're now taking photographies of the products with white backgrounds. Since there's less noise on the image, this model would perform amazingly, right?
Yeah.
Add a noisy background or with a lot of texture or whatever, the model might have a little blips here and there. The model would support this use case very well. We tried it out and it was like, wow, it kind of showed that we can get a high lift of productivity because of how the use case was set up from the customer and the fact that the model performed very well. And again, this case was for images. So SAM-V2 or SAM-V1 would have also been working. But the fact that as we start ingesting now videos, the fact that my pipeline already works with SAM-V2, I was able to kind of just move it to a new project and it was seamless, like the pipeline was already in place.
I love it when a plan accidentally comes together.
Absolutely.
Now, to anyone who's ever done annotation, this idea that a mask would kind of be automatically applied, that's probably pretty exciting. That removes like a good amount of the manual amount of work. There is, however, this concern of like, okay, today it's just automatically finding the bounds of the thing you want to mask. Is the end goal of this economizing away that human labor completely? I guess my question is, when you view SAM-2 in particular, how much human must remain in the loop?
I think there could be two questions for this. Like there's a philosophical question and a more like the pragmatic answer. Right now, from what we're seeing from our client, there's always a need for a human in the loop. You need someone to figure out the edge cases for your generic business case. Let's say you're annotating cars. Maybe there's specific cars that you want to annotate in a specific way with specific rules, and those rules are not ingrained in the generic tool that Meta provides us.
I can give you an example of like how this model could perform or not perform. But for example, we want to annotate a car, like Pascal mentioned. Some customers might say, like, I want the car to be segmented, but without the mirrors, because we don't care about the mirrors. But SAM won't make the difference between the mirror or not. It will take it with the mirrors. And then how do you tell that model to say, don't take the mirrors. So you kind of have to do more manual intervention to remove those aspects, potentially retrain the model to, when it detects a car, to not take the mirrors. And again, the mirrors, when you're looking at the car from the side, you don't care. But when you're looking from it from behind or the front, those things need to be removed. So how do you have a model always kind of interpret those customer requirements? Means that we now have to have a human make those slight adjustments, right?
Also, side note, but some can have positive or negative examples. So you could like do negative example on some part of the object that you don't want. But to Yannick's point, you do need a human to make the correction, and you need to have an efficient way to get people to do those corrections and be it smooth and efficient.
So we're not going towards a world of 100% automation, but think about it more of like in a world of labeling assistance in a way. We're trying to give the proper tools to humans to make the right decision, but then accelerate things that might require, as dumb as it sounds, to click all over the place to highlight something. Maybe the idea is to click once, maybe 2 or 3 times to remove or add missing parts, but then having the rest of the model kind of, even if like we're taking even the temporal aspect of it, which is going to be very important with SAM-2, is that in the next frames, it keeps those clicks that you did negatively or positively to continue tracking those pieces that you might have missed the first time. So that's what's really interesting. That it's really, we haven't touched on it yet, but is that extra layer in SAM-2, which is like a new kind of, layer in the model, which is called memory, right? How that gets kind of like, basically SAM-2 is really just SAM-1, but with like a few extra components to it, and memory being one of the main ones, where it can look back on previous frames where things are annotated a certain way with certain inputs and maybe positive and negative outputs, and take that into consideration in the next frame. So you don't start from scratch. It kind of takes into, in its inferencing, all that information from previous temporal inputs.
I'd say like one of the main challenges is, okay, you have this fantastic tool that can have positive and negative points. It's going to generate some mistake from time to time. How do you provide the best user experience to annotate in the simplest and most efficient way with complex requirements from clients? How do you actually integrate this and not overwhelm the user, make it smooth? That's the real challenge, in my opinion.
The complex requirements piece is the operative, I think, thing here, because it's segment anything, it's not segment everything. And when you get down to that last X%, that last 10% of like, but we need it. The mirrors example, I think, is very instructive, right? And it's maybe not even economical for Meta to teach it to do that, whereas it would be for a specific client use case to train the last X% of it. So that feels meaningful when it comes to taking something that is presented in this splashy, shiny demo. It's very fun to play around with, translating it into a real use case that can work for a company and not just a user who's having fun, not just like the version of my mom using ChatGPT to get a new recipe. This is where it starts to get really, really interesting. So I would love it if you guys could share some of the use cases that you foresee SAM-2 kind of enabling.
One of the big ones that I see where there's like the most added value is really around tracking, right? Like we do a lot of, or a lot of people will boast that you can do linear interpolation. You annotate frame 1, you annotate frame 15, and whatever happens between 1 and 15 will, in a linear fashion, on every frame basis, adapt, right? But then on some frames, the shape doesn't match anymore because it's a linear interpolation and not a dynamic interpolation. Now with these kind of mechanisms, you can do tracking and also have more, let's say, dynamic resizing as you're like, and you only have annotated maybe a few frames, but what happens in between, because the model can adapt in a more dynamic fashion, reduces the level of effort for longer sequences. So that's where I see myself utilizing this a little bit more. Another use case that I see is for more precise, let's say, or I call it snapping, which is like you have a traffic sign, you want to put a bounding box on top of it. Well, maybe instead of being super precise and annotating it, you can be less precise and the box will snap because it detects the object you're trying to detect in it, and it will create like the bounding box around the mask. It says like, oh, this is a traffic sign. Even if it's a triangle or whatever shape it is, it will find the proper sizing, and it removes, again, the effort of like being super precise on the pixel, dragging and going and finding the next click. You can kind of go more rough annotation, and then it does the redefinition. So those are kind of like little efficiency gains you can get from the tooling.
I think as those tools evolve and become more and more precise and more fast and efficient, there'll be some kind of baseline tool that you can use in many types of workflow. If you need to draw a polygon, like we need to solve for how can you correct a pre-annotation faster than doing it from scratch when it's not perfect. But I think this delta will become smaller and smaller as time goes. And maybe people will have to only click on the shapes that they want and have a even quicker way to correct the shape if it's not perfect. But SAM and SAM-2 kind of try to solve for a lot of things in 2D, like you said. Because you can run SAM on a single image and try to generate polygons all over the place and use those as pre-annotation for some of your shapes of interest. You can build interaction in the UX with that also. But it's always in my mind about how do you fit with the user and how do you provide the best interaction to be the most efficient.
Yeah, the auto detection, the example you gave, Yannick, that is just such a straightforward quality of life thing that you expect from like V1 to V2 of a product. So it's just a very cut and dried, I think, efficiency gain. And it seems like that is what it keeps coming down to for use cases is a productivity and efficiency gain, and then to some degree, automation. Would you agree?
That's what customers are asking for, right? Because they are getting or collecting more and more data, and they need more and more data to trickle into their models, and they need some type of labeling. We are in a very interesting time period where a few years ago, everybody was building a little bit more of their custom models, but now with the advent of open source models like Meta has made available, has now given everyone the possibility of fine-tuning these models, using them into prototypes and whatnot, and realizing that yes, there is a easier way to automate using state-of-the-art capabilities. But the thing is that there's still an education that needs to happen on the customer side to say, like, if you try to automate too much, don't expect the same level of quality. We're kind of shifting in towards more of a validation kind of period than just like annotating from scratch. Annotating from scratch will still happen sometimes just to start off a project. But now more and more, since these tools are made available to everyone, people are saying like, hey, can I just use this, send you the annotations that I have, and you fix them? And kind of what Pascal was saying earlier, we are working very hard with our product team to say, like, what is that experience for associates to ingest the pre-annotation, like visualize them in a way that they can easily edit them, fix them, refine them, so that the main output at the end for the customer is these like ultra high quality, like exactly what their model needs. Or, we say that we do sometimes data to train models, but sometimes also we have to deliver extremely high quality because they want to use that as evaluation data set. They need to use that as a baseline to benchmark the performance. So they can't have bad annotations trickle through and then run benchmarking on bad annotation. They need things that are like almost like 99% perfect so that they can see, is my model drifting or underperforming and whatnot. And you can't do that, I believe, with like SAM right now. But the idea is that it's moving towards.
I think it's interesting to think about this whole thing of correcting like model validation, correcting pre-annotation. We tend to think about it really always in the context of a single frame. I have a bounding box and I'm correcting this bounding box, or I have a polygon and I'm correcting this polygon. But when you start having sequences and you start having this time dimension, it becomes way more complicated. You have objects that are tracked through times. There could be mistakes of objects that get inverted. You could have objects that used to be seen before in one of your camera and maybe are seen after in the second one. Like the mental load of correcting this versus doing it from scratch, there's really something that needs to be figured out here. And it's an interesting problem.
That is such a challenge because whether it was more efficient to do it yourself or to go in and validate, you probably don't know until you've gone in and validated, right? So you kind of have to climb to the mountaintop yourself to see if it was worth it. Is there a better way to figure out whether this is worth it before you spend all this time figuring it out?
We've run many experiments with customers, and often it comes down that because of we deal with in complex use cases, we're not like, I make a difference between a cat and a dog anymore. That's been resolved. But in some of the use cases, especially in autonomous vehicle, the stakes are so high for safety and security that quality has to hit sometimes like thresholds of 98%. And relying on models to do a lot of the work, it gets too tricky to tell them like, oh, we're going to spend a lot of time to automate all of this process. And again, they have usually very tight deadlines. So we tend to work in parallel to try to find ways to become more efficient. And there are other ways, like we talk about SAM-2 a lot, but there are many other ways other than just models. Like it could be optimizing the workspace to reduce the movement of the mouse between selecting an attribute. As silly as that, save 5 seconds times 100 million times. It's a lot of hours saved. It's that silly sometimes. But models have their place, but they need to be evaluated. And so far, we've done about, in my personal experience, about like 20 experiences with models, and only about 3 times did we see a huge enough lift for the size of the deal that it was worth to like implement and have that like regularly running. Compared to the others, because of the tight timelines, the potential of error, and the high quality stakes, if some of the customers understand and you explain it to them and they're like, you know what? No, I want everything from scratch because I can't have a car potentially like, I'm going to say that, but hitting a vulnerable road user, like anything that's squishy. You don't want that ever happening ever. All of these models, it works well. Like there's always the element of demo candy, right? I think you mentioned that before, Rob, in terms of you go on the Meta website, you click that all the videos are like 4K, high frame rates.
Yeah,
like everything
it's Serena
works.
Williams. Exactly.
Amazing, right? But then you bring in real data where lower FPS, the tracking and the segmentation doesn't work as well, but still okay. But then add on top of that, the fact that when you deal with real customers, that the data sometimes is grainy. The data is dark, maybe a lower quality. There's rain, there's snow.
It was cloudy that day. Yeah, exactly.
There's really something interesting in annotation is that when you are in the ML space, you always think of ground truth as something that is absolute and always true. And you don't always fully appreciate how things are subjective. And you pay to get one person to annotate it, but sometimes if you were to ask like 5 different persons, you might have different ground truth per se. And there's this whole aspect of consensus that is really interesting. And if I send you a bunch of pixels that are like 300 meters away and I ask you, is it a truck, a car, a vulnerable road user, and is their lights on? And how much are they occluded? Are you going to be able to, figure it out?
It's exactly that. And more and more, we're like trying to educate customers that the tool needs to be made available, but never expect something like, I send you data and before it even gets to a human, everything will be annotated and all they'll have to do is like, yes, no on stuff. No, they want more than that. They want like, yes, this is good. This is not good. And at the same time, when it's not good, re-edit it, change the attribute, like do all this extra work without thinking that, the level of effort compared to doing it from scratch sometime is just about the same because you're still revisiting all the objects that are there. And same thing, we're trying to educate them to be like, is this really needed? You're giving me a hard time about this one pixel because there's a button on his shoulder that you want me to include in the thing, but is that going to make or break your model? Because all this back and forth going around this, like is costing both them and us time and money to readjust. And sometimes, yes, sometimes they'll put a use case. In other cases, we'll be like the example that Pascal mentions, like maybe we don't need to go 300 meters away. Maybe we focus on anything that's just like in a region of interest of 50. Redefine the scope of the work that's required. And then we can start thinking, okay, now models in this kind of range work better. Now we can utilize a little bit more automation here. Not on everything everywhere.
I said I also had a philosophical point early on. If we ever ended up to a point where you just like run something through a model and get everything, you'd have a super model that you could send text into and then get all your annotation that you want out of the box, then why would you want any kind of annotation and not just use this model directly if it's perfect? Like clients are using this to either evaluate or train their own model. If there is a solution out there that can solve it out of the box without any kind of human inputting things into the edge cases, then there's no value in training anything in my mind.
Another good example is if we had the model and had everything trained on our end and it did all the auto labeling for them, why even do labeling? Just license our model or license our version of the model. And some customers sometimes expect when they come to see us, like, you don't have a model that does exactly my super niche use case. How come you don't have this already? I'm like, well, it's because clearly nobody else does. You're working on a very unique problem, which is great, but you need to have human in the loop. The RLHF kind of concept, like, is still present and still going to be very relevant. But I think it's shifting in towards more like, let's do a first pass with models. What type of experience does it look like after to have the associates fix it? And how can our customers also validate this is what it looks like when a human goes through it, and this is what it looks like when a model does it, and kind of seeing the evolution. And then they can make decisions to be like, you know what, the model was good enough. All the extra stuff that was done by the human, it's better, but maybe our model doesn't need it. And then it's a conversation to have. But the idea here is that, again, client requirements, client expectations, and again, safety, guardrails, and all that kind of stuff comes into play when trying to define a solution for our customers, which we have to be honest with them. We have to educate them. Like, we are experts in this field. Myself, I've done over 300 projects in annotation that vary from Gen AI to sensor fusion to just static 2D to sequences and all sorts of vectors. And sometimes we also learn something that we can then share with the customers. The idea here is that we want to be a great partner in this space, but also we want to set realistic expectations in terms of what models can do. I think there's a lot of hype out there that, oh, models are going to replace everybody and everything, and nobody's going to be able to work, and AGI is going to like take over all over the place. There needs to be checks and balances. And I think that people are realizing that human in the loop is still very important. And let's have a conversation around like what your use case is and what we can put in place to really automate. The reality is, what can you do to get the most bang out of your buck, basically?
Certainly. And that coaching that is necessary to help someone arrive at what they actually need. What is, as you said, Yannick, good enough? Or as you said, Pascal, what is consequential? Like, oh, this partly occluded light 300 meters away. Wouldn't it be great if the model could measure that? I guess, but who cares? Does it actually have an effect on the performance? And if not, just cut it. It's that simple. But this is also related to just the utility of an off-the-shelf model. This comes up periodically on the show. Oh, models are being commoditized. They're open source models. Take one off the shelf and do what you want with it. It will have some cool functionality out of the box. But how relevant will it be to your needs? How relevant even can it be to your needs? I think is the important thing there. Now we get into the realm of prognostication a little bit, but I would be curious what you both think about that last point. Will models sufficiently advance to the point where there is an LLM, you can ask it for what you want, it will automatically be able to address your use case?
I can speak a bit from my background. I've been working for the last 6-7 years in the data science realm. And I feel like it's always a matter of really understanding the business problem that you're trying to solve. You're never just using a model for the sake of using a model. You're trying to solve for something and you're trying to improve a business metric or whatever. And those are always specific use cases that you're trying to solve. Are you trying to reduce the time it takes to annotate? Are you trying to improve the value that you're going to have in whatever other project? So from my personal usage, I've had the most value out of the LLMs when I'm trying to do something where I also have a bit of expertise. Like not asking something in a coding language that I don't know anything about, or maybe just grasping the high level syntax, but inputting something very specific with the right keywords and with the right business knowledge gives me the most bang for my bucks when I'm using those kinds of tools myself. What I'm trying to say is that I think the model with the right expertise is where you'll have the most synergy and the most bang for your bucks, in my opinion.
Correct. And we could do two type of analogy, but if I were to take a OpenAI and Anthropic kind of approach to when you try to prompt these models, ChatGPT will be more upfront to try to get you an answer right away, like a one-shot type of approach. Compared to when I interact with a Claude, let's say, it will ask me a couple of questions. It doesn't give me, it's more of an assistance, oh, you asked me for this. Do you want me to go more down this route or more down this route? It's trying to participate in the conversation to get you the best result because maybe you didn't prompt it. It's kind of questioning your initial prompts and having more of an interaction kind of approach. And that's how they built their product. ChatGPT seems to be more really more of a, I ask you this and give me everything without having a conversation, just give me everything as I want it. And like Pascal said, with the right training and expertise, you can really extract more out of those tools to get to a certain point. And I've mentioned that earlier when we started talking about SAM-2 is the same thing, is you can make these tools for AI assisted type of labeling, but it's a tool that just helps the associate work a little bit faster when they know when to use it, like the right use case. If it knows that the object is well defined, there's good lighting, like I can visually see sharp edges on the object. If I click here, I'm going to save a lot of time because I know it's well defined. But an object 300 meters away, fuzzy, not clear where the edges are, maybe I should use another type of tool. So again, educating the tool user of when they can get benefit or not from the application of that technology is where like we'll get the most bang for the buck. It's really kind of training the user properly.
I think there's something to be said also about like when you're using an LLM, knowing when it's wrong. Like sometimes the answer that you're going to get is going to be just a generic answer because you may have asked something very specific. And there's something to be said about, like you said, Yannick, knowing when the tool is not going to be the right tool and actually solve it yourself and not trying to over rely on it.
I think there is a healthy amount of distrust that we still must have with generative because it's going to tell you something. It's never going to say, I don't know. And in the event where it coaches you a little bit to ask a better question, we're getting there. But right now, for example, with ChatGPT, you have to ask it to ask you. I've seen that prompt. It's like, evaluate my prompt and tell me how I can make it better. Shouldn't it just be doing that automatically? Anyway, that's a side point.
You know, it's a bit like in the end, like before ChatGPT, you were doing a Google search for the information. And the information might have been on Stack Overflow, might have been on different places, and you'd still had to have some critical thinking in what you were seeing. And I think it's the same with LLM.
Now, when we speak about efficiency and getting those bang for our buck, I don't think you can have a complete conversation about models like this without speaking a little bit about the economics. Because right now you have these open source models you can take off the shelf. They're free, right? Well, this compute is fantastically expensive. Feels like we are in this V1 version where a lot of it is subsidized by venture capital. In this moment, though, where is the cost of running these models and this compute being burdened? Yannick, I'd like to hear your take first here.
Well, to kind of go back a bit to the beginning of your question is that I think there's hope from the industry that compute will get cheaper and that there's going to be suddenly a unraveling of a new technology that's going to make these models run on the edge with X number of billions of parameters. And hopefully, I think the VCs are hoping that there's going to be eventually a line that gets crossed where like, okay, now it gets to a point where we can actually charge the $20 a month to customers and we're breaking even, let's say. And that's already a pretty good line to cross. But at the moment, clearly with the training, the research investment and everything that goes into it, who's paying for it? Clearly the VCs. Now for us on our side, when we want to run these models and we want to offer some of these efficiency gains to the customer, well, there's ML ops costs, there's infrastructure, there's GPUs. And again, that's using off-the-shelf model. If you want to start fine-tuning the model a little bit, then you have to go into training cost and data acquisition and data pipeline. So there's a lot of stitching together that is kind of like black magic to a lot of folks using some of these free tooling. But in reality, there's like quite a bit of tech besides just the transformer technology behind the scene that is making all of this run and quickly too, right? You don't want to wait 5 minutes for a response to show up. You want it to pretty much stream in and be pretty quick. So I find that there's a hidden cost that a lot of people think to assume like, oh, just use this model. It's going to be 10 times cheaper. Well, not really. Who's paying for the inference cost? I don't know, Pascal, if you have any.
I think you pretty much sum it up. There's a lot of hidden costs with running models. It's not free. And in the end, it's your provider that is paying for it. So yeah, it doesn't come for free.
It feels like it is inevitable that this cost will eventually be passed down to the practitioner. And so if you are a practitioner in this space, your efficiency gain case must be rock solid because your CFO is going to knock on your door and ask you if this is really worth it. And you better be ready to go to explain why it is. And so whether that's the efficiency gain, the productivity, however you can tie it to ROI, that is a skill set that I think is not typical for a lot of technical folks, but it is more and more important that you're going to have to go outside your comfort zone and make this business case, make a PowerPoint, I don't know, to argue for this.
If I can jump in on this, because we've had experience through that. Again, we really shouldn't underestimate the human aspect. We're using models, but in the end, you have a team that is working on the ground and using those models. And there's a huge aspect of coaching people, of like organizing the work so that you are actually going to get your ROI, because you can provide the tool, but if no one is using them, then you get no efficiency. And that's, I think it's a human thing in the end more than a purely technological tool. And this is something that, especially like on the technical side, sometimes we're not used to it. That's why there's a need for AI product manager and more intermediate between pure research and actually the business.
I would agree that the AI human meshing like in the product is a whole new discipline of like making it easy to use, easy to trust. And then of course, having proper trainers, making sure that this can scale, especially in our business in a way that everyone is using it and not just a select few, right? If we're going to also do the investment on our end to maximize the efficiency of these new technologies, are we putting the efforts in the right place to develop the proper experience, not only like segmenting, but like editing the mask, validating the mask, creating new tooling to visualize potential predictions without actually doing the annotation, just so that before you do, like there's all these tons of experiences that could be run about how can we create an experience for our employees, but also customers who will be interacting with our platform in the data eventually to kind of make sense of what's happening with this tech, kind of like opening up the black box a little bit and create those experiences. And we're working really hard at doing all of that kind of stuff. It's just that, again, sometimes there's hits and there's misses, but the idea is that we have to iterate quickly. And we've got a few wins recently, and we're going to try to continuously improve on that, nonstop for the years to come. Like I said, who knows? Maybe SAM-V3 comes out in 6 months and the whole paradigm changes again. So we have to pretty much have like our finger on the pulse to see how things evolve.
Yeah, constantly.
Still on the cost thing, because I want to kind of make a mention, right? There was an interview recently with the CFO of OpenAI who are still talking about like, we haven't figured out pricing. We are making money, but we don't have full understanding of inference and infrastructure and all that and how that will eventually translate. So back to your analogy of like the Ubers of the world or whatnot, and we suddenly see a sudden price jump. VCs are in it for the long run, but there will come a time, we don't know when, maybe in the next 2, 3, 4 years, where there will be a shift to be like, no, you need to go into profitability mode. And then who are going to be the players that are going to survive that shift? Because if you're used to paying $20 a month for OpenAI and the compute hasn't caught up or whatnot, and let's say they now need to start making a profit, well, do they suddenly jack up the price to $100 a month? Some people will stay, absolutely, because they'll see a benefit. But will everybody have that kind of luxury to afford that kind of service? Who knows? We don't know really how that's going to play out in the future. And we're trying to be on the side of being mindful of that and that we want to use it. But at the same time, if we're using these models, it shouldn't directly translate into like 10x cheaper prices. Like we still need humans to adopt it, use it, and we need to find the right use cases to really kind of take full advantage of the efficiency. Right now, it doesn't seem like it's always the case. We really need to be experts in our field and educate the customers about what can and cannot be done.
I feel that maybe I'm wrong, but I think that there's a feeling in the VC space that people are rushing and hoping that there will be AGI anytime soon and that this will kind of solve for everything. And I don't know how much that bet will pan out. And I'm really curious to see how it will go, because people are pouring down a ton of money to train bigger and bigger models. And I guess the hope is that those models will be good enough that they'll solve for everything and you just pay for inference. But it will still cost money.
Yeah. Seeing the benefit is so crucial because if you are listening to the show, you are, I imagine, sufficiently technical to see the benefit right away. But will the rest of your organization? And this is a challenge for practitioners in this space. If you're like a Python developer, no one doubts the value to the organization. You're not about to get pulled into a room and be asked, what is it you say you do here? But I fear, like you both, that there has been this willingness to try and this willingness to invest. And at a certain point, it's going to have to justify itself. And I think it's going to have to be on the practitioners to make that case to their customers, to the organization, to whomever, if they want to keep playing around with these fun toys.
And, like through my career, I've been through multiple cycles. There's always new innovation coming in. And like there used to be RPA at some point, robotic process automation. There was the early days of data science where we would all be like training models internally and solve. Like there's always this cycle of we hope to have this new technology that's going to solve for everything. And then we adapt and we need to have real life project that brings in ROI rather than like demos. And it's always ongoing, I think.
And it's also, there's a kind of discrepancy between what tech leadership of some of these more incumbent industries, let's say finance, insurance, that are at the top who are not willing to make large bets yet because it's a lot of money to invest. And at the same time, they're betting a lot more on the human connection. You want to deal with your financial planner. You want to deal with your insurance broker. They value that human interaction with the different clients that they have. And even though some products are becoming direct to consumer, a lot of this still relies a lot on connections and relationships. So what are the use cases that some of these larger organizations who want to utilize automation and tooling, what can they build to kind of benefit that clientele of maybe I would say bottom of the pyramid, like their main employees. And at the bottom, they're like, oh, there's great value. We would like to have it. But then there's also a bit of concern, like, am I going to get replaced? Am I going to become a chatbot that's going to sell insurance? And it's to find that compromise between what can be done to automate to not put those relationships at risk, but make them more efficient, get better results. And then at the top is how much is it going to cost? And do we even want to make that type of investment? So when I went to a few conferences, you kind of see like at the bottom, people are like super excited, but with a little, maybe a sprinkle of concern. And then if you talk to like people at the top, they're like, we're just kind of exploring. It's still very early days for them, even though all this hype has happened over the past 2.5 years, maybe 3 years. They're still like, we are being very mindful of that's not our business. Like, what kind of tech stuff can we? But again, eventually you will have to adapt. It's kind of saying like, oh, we never want to use email because we're used to paper, but there needs to be a little bit, I think there's a bit of a blockade of making the funds available at the top and at the bottom, an eagerness to use some of this tooling, but how do you define a use case that's worth getting the money from the top? Because the ROI, again, is hard to quantify. So there's a little bit of a war happening internally in terms of these big companies, in terms of politics, about the bottom wanting and the top not wanting to invest just yet until they find the perfect use case,
Yep. I see it too. Well, gentlemen, we are creeping up or perhaps well past optimal podcast length, but it's just because I've been having a ton of fun chatting with you both today. So we're going to have to wind this down. But before we go, I would just love a teaser trailer. What is coming down the pipeline? What's next for the SAMA reading room?
There is a paper on different types of multimodal type of experiences that have been done in the wild. So trying to get a sense of identifying ambiguity in like multimodal. So if you and I were to review the same video and we had to caption it and explain what's happening, how would you describe it versus me? How can we get to the same conclusion but use different words? And kind of defining how does that kind of information get packaged together to eventually like refine a model. So there's all kind of like these, and again, Pascal's really good on this whole kind of philosophical type of questions about like how that kind of get put together, how our brains work to kind of utilizing a very common tool that could give the same output, but how can we give it two different inputs and still get the same output? It's a pretty interesting problem.
Multimodal is all fun and games until you appreciate that there's no such thing as an objective experience of reality.
Yeah, and this is a really interesting topic. Like something that really is close to my heart is like, how can you leverage different cultural biases? Like we've done experiment with voice and people see things in a different way. If you look at a bunch of logs on a river, for Canadian, it might be a beaver dam. And for other people in other countries, it might just be a bunch of logs. Can we leverage this? Is there value for the models in that? Like there's really something interesting on this front, I think.
Localized egocentric perception, perhaps?
Yeah.
Something like that, yeah.
That's a whole different podcast episode or maybe a series of them. We simply have to wind down. But gentlemen, this has been really great. Pascal, thank you so much for being here. Yannick, this has been fantastic.
Thanks.
So thanks for doing this show with me. I love chatting with you today.
Thanks so much for having us and looking forward to doing it again.
Can't wait. Hell yeah.
Thanks.
How AI Happens is brought to you by SAMA. SAMA's agile data labeling and model evaluation solutions help enterprise companies maximize the return on investment for generative AI, LLM, and computer vision models across retail, finance, automotive, and many other industries. For more information, head to sama.com.